So if you look at part 4 here, uh, we could use L'Hopital's rule on these ones, and in fact, in some of the cases, I would rather use L'Hopital's rule. Just I think it would be more efficient. But it's also nice to know that Maclaurin series, um, because they are an approximation around x equals 0, then you're able to use them to find the limit because they are just as accurate as the original function. So if I look at part A, sine of x minus x over x cubed, I'm just going to use the formula for sine of x. So we know that sine of x, and you should be able to construct this, but rather than construct it every time over and over again, you should be able to just kind of jump to the formula. So it's an alternating sum of the odd powers. So we have minus plus minus plus. So if I rewrite part A then, I'm going to say then that sine of x minus x over x cubed, well, I know that this is sine of x, and so I subtract away the x from that, and I have negative x cubed over 3 factorial plus x to the 5th over 5 factorial minus, I can kind of squeeze x to the 7th over 7 factorial, and on the bottom is x to the 3rd. And so I can knock off an x to the 3rd from everything that's in the numerator, and then I won't have a denominator anymore. So if I knock off an x to the 3rd, I get negative 1 over 3 factorial plus x squared over 5 factorial minus x to the 4th, I suppose, over 7 factorial, plus I guess the next would be x to the 6th over 9 factorial. And I'm going to take from the problem the limit as x approaches 0. So really all of those other terms are irrelevant beyond the first term, and we end up with negative 1 over 3 factorial, which is the same as negative 1/6. Now I want you to think for a second, had you done L'Hopital's rule, you would have needed to do it 3 times. If you tried plugging in x equals 0, you'd get 0 on the top, 0 on the bottom. You take the derivative, you would have 1 minus 1 on the top and 0 on the bottom. You take the derivative again, you'd have 0 over 0 again. You take the derivative again, then you would get 1 over 6. And so the Maclaurin series may be more efficient here because of how many times you would have had to iterate L'Hopital's rule. Okay, same thing on part B. To be honest, part B is one that I would definitely have done L'Hopital's rule on because it only takes one of them, and then you're good. But to show it with Maclaurin series, I will just show remembering that e to the x can be replaced with 1 plus x squared over 2 plus blah blah blah. And so if I have the numerator e to the x minus e to the negative x, we're going to have, let's try to fit all this on here, 1 plus x squared over 2 plus x cubed over 3 factorial dot dot dot. That's e to the x minus e to the negative x is 1 minus x plus x squared over 2 because when you square the negative, it becomes positive, minus x cubed over 3 factorial, and then dot 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 there, and all of that's going to be divided by x. There's going to be so much nice canceling here. In fact, all of the even powers will cancel out, and so that leaves us with just 2x plus 2x cubed over 3 factorial dot dot dot, and all of that gets divided by x again. Sorry, I'm trying to squeeze it in there. And so that leaves me with 2 plus 2x squared over 3 factorial plus dot dot dot. And as we do the limit as x approaches 0, we get our answer of 2. So maybe easier than L'Hopital's, maybe not, but it's just another tool to keep in mind.